Today, we're going to crack open the engine of modern software and really look at the building blocks of C. These are the absolute must-know essentials for telling a computer what to do.
So how do you actually tell a computer what to do? It sounds like a simple question, right? But the answer gets pretty complex, and it all starts with learning the language. See, computers don't speak like we do. They speak in code, and that code has a very specific set of rules.
And that's really our goal today. We're going to give you the vocabulary and the grammar to start speaking C. By the time we're done here, you'll get how to build the basic instructions that all those complex programs are made of. Let's start with the nouns.
Okay, first up, every single language needs nouns. Words to name people, places, things. In C, we call these things identifiers. They're basically the labels for everything you create.
Think of an identifier as a label you slap on a box inside your program's memory. This name lets you find that exact box later on. But, and this is a big but, you can't just name it whatever you feel like. C has some really strict grammar rules you gotta follow.
Now, these rules might seem a little picky, but they are absolutely crucial. They prevent any kind of confusion, both for you and for the computer. That case-sensitive rule, for example, it's a huge deal. To the computer, age with a lowercase a and age with a capital A are two totally different things, like two completely separate boxes.
So these identifiers, these labels, they get stuck on two main kinds of data boxes. You've got your variables, which are like boxes you can open up and swap out the contents whenever you want. And then you have constants, which are more like sealed boxes. Once you put something in, that value is locked in for good.
Okay, so we've got our nouns to name things. Now we need our verbs, the action words. In C, these powerful little symbols are called operators. And trust me, they do all the heavy lifting.
Yep, these are the symbols that do all the actual work in your code. Everything from simple math to the really complex comparisons that let a program make decisions. And they come in a couple of different flavors.
So you've got two main types. Unary operators are simple. They just work on a single thing, like making a number negative. Binary operators are way more common. They connect two things, like adding A and B together.
The first set of tools we're going to pull out of our C toolkit are the arithmetic operators. These should look pretty familiar, because they handle all that basic math you learned back in school.
You'll recognize almost all of these, right? Addition, subtraction, multiplication, division. But take a close look at that last one, the percent sign. That's the modulus operator, and it's kind of a programmer's secret weapon for doing things like figuring out if a number is even or odd. All it does is give you the remainder of a division.
And here's a perfect way to see it in action. If you ask the computer, what is 10 modulus 3, you're really asking, what's left over after I divide 10 by 3? Well, 3 goes into 10 3 times. That gets you to 9. And the amount left over? It's 1. That's your answer.
Okay, so math is great, but programs need to do more than that. They need to make decisions. They have to compare things. And that's exactly where our next set of tools, the relational operators, come in.
So unlike the math operators, these don't give you a number back. They answer a question with a very simple true or false. And hey, pay close attention to that double equal sign for equal to. Using just one equal sign here is a super common mistake for beginners. That true or false result is literally how programs decide what to do next. For instance, a program could check if someone is old enough to vote. It would ask, is the value stored in age, which is 17, greater than or equal to 18? And the answer is nope. The computer just sees that whole question and boils it down to one word. False. But what if you need to check multiple things at the same time? Like, is the user logged in? And do they have an active subscription? For that, we use logical operators to string our checks together. These three symbols right here, they're basically the brains of the whole operation. You've got the double ampersand for and, those two vertical bars for or, and the exclamation point for not. Seriously, learning how to combine these is what separates a simple script from an intelligent program that can handle some really complex logic. C was designed from the ground up to be efficient. And because of that, it gives us some really handy shortcuts for common things, like assigning values or making small changes without a bunch of extra typing.
So the most basic one is just the equal sign. But then you have these compound operators, like plus equals or minus equals. These let you do a calculation and store the result right back into the original variable, all in one quick move. So a plus equals 5 is just a cleaner, faster way of writing a equals a plus 5.
All right, now for a classic C gotcha moment. This is one that trips up so many people when they're starting out. Both ++a and a++ add 1 to the variable a, but the timing is completely different. Pre-increment, with the pluses before the a, changes the value first and then it gets used. Post-increment, with the pluses after, uses the original value first and then adds 1. That tiny difference can cause some major bugs if you're not paying attention.
All right, we have covered a lot of ground. But what we've really done is assemble the most essential tools for our C programming toolkit. We've got our nouns to name things, our verbs to make things happen, and the grammar that makes it all make sense.
It might seem simple when you lay it all out like this, but with just these building blocks, you can start to write real, meaningful instructions. You can name data, you can store it, you can do math on it, and you can make decisions based on it. This is the absolute foundation. Every complex application you use, from the operating system on your computer to your favorite video game, it's all built on these exact same principles.
So think about it. With this toolkit we just put together, what's the very first instruction you would write? A simple calculator? A little program to check if a number is positive or negative? The possibilities are now wide open. The next step is just putting the pieces together.